We're going to be recording data a lot this year, so let's learn the right way to do it. Now, a there's two types of data. There's qualitative and there's quantitative. Now, you've heard this before. Qualitative is just going to be non-numerical information contained from an observations, normally what you see or what you smell, what you hear, anything using the senses. But quantitative is numerical information contained by usually some kind of measurement, like a temperature or mass. Now, all of these measurements are always associated with uncertainty. So you will always have three parts to every measurement. That's the quantity, that's the uncertainty, and the unit. So let's say 9.0 plus or minus 0.1 centimeters or whatever. Okay. So now that uncertainty is recorded from here from an analog. Now let's burn this into your brain right here, because the analog one is going to be the smallest graduation divided by 2. So if we look at this and you really look, it goes up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so each increment is worth 1, right? The 1 increment. So divide that by 2, and it's 0.5, right? So let's find that value. That's going to be 20, 1, 2, 3, 4, 5. So that's going to be 25, right? But that's a little bit above 25, so we're going to estimate that one extra digit. Make sure you estimate that one. And we'll just say 25.3. And because we're not so sure about this, we are a little uncertain. That's why we have that uncertainty. That lets us know, and it lets the reader know that's how close my equipment was, and also how sure I am of this. So this was the guessed digit, or the uncertain digit, and this is our uncertainty. And let's go ahead and call that milliliters. Now for a digital balance, let's say we're looking at the balance right here, looking down at it, and this is the balance part, and this is the little digital reading. And if it's just reading nothing, if it's reading 0.0, the uncertainty for that is going to be 0.1. So you're just going to take that last digit and you're just going to put a 1 right there. Okay. So that would be for a balance or something like that. That's the easiest one. So let's talk about accuracy and precision. Now, you've heard of this before. Remember, precision is the closeness of agreement between different results, and then the accuracy is the closest of the agreement between the experimental value and the accepted value. So how close it is to the accepted value, that's the accuracy, A. And the precision is how close they are together. You can use the dartboard, and if they're all close together, right here, then they are precise. But let's see, here's our bullseye, right? But if they are on top of the bullseye, then they are accurate. And these would be also considered precise, okay, because they're so close together. So now that is going to help you determine, and then the next part is to actually quantify like how accurate you are by calculating the experimental error. You'll do this in as many times as possible, and hopefully you should do this in your IA as well. So the percent error is the experimental result minus theoretical result divided by the theoretical result. That should have an absolute value on it, because sometimes this one can be positive or negative, and we'll multiply that by 100 and make it a percent. So the students got an experimental result of 25. So 25 minus 23 divided by 23 times 100. And that student is pretty close. They get 8.70%. All right. And we'll cover on how we could actually evaluate this a little bit later. So that's going to be it. Thanks.